Hello guys, welcome back to my channel Algorithm Avenue. In this video, I'm going to make an interesting announcement that I'll be creating an end-to-end machine learning playlist for our channel. Okay, this is the only machine learning playlist in English which contains all the techniques from data gathering to model deployment. Okay, now before diving into the video, I'll be making a small request that you're watching our videos but not subscribing to the channel. So please consider subscribing to the channel, and if you have any doubts or wanted any changes in the teaching, please feel free to comment in the comment section. Okay, now let's see all the topics that we'll be covering in this playlist. Okay, first is gathering the data. Okay, we'll be discussing all the techniques to gather the data from different sources. Okay, second is data analysis. Okay, data analysis is an important step in machine learning. Okay, first we need to understand the data so that we can train our machine learning model. Okay, third is data pre-processing. Now to train a machine learning model, we need to give the data as input. Okay, now before giving the data as input, we need to apply certain pre-processing steps. Okay, we'll be discussing all the pre-processing steps involved in this section. Okay, fourth is algorithms. We'll be discussing all the algorithms from linear regression to XGBoost. Okay, fifth is techniques to improve the performance of the model. Now we have trained a machine learning model on a dataset and it has given some results. Okay, if you are not satisfied with the results, to improve the performance of the model, we have certain techniques. Okay, we'll be discussing all the techniques in detail. And six is model evaluation techniques. Okay, now our model gives certain results. Okay, now to understand why the results are like that, we use model evaluation techniques. Okay, seventh is interpreting the model, and eighth is model deployment. Okay, these are all the topics that we'll be discussing in this machine learning playlist. Okay, now from the next section of the video, we'll be covering our first topic, that is what is machine learning. In this section of the video, we'll be discussing our first topic on machine learning, that is what is machine learning. Okay, now let's see the basic definition of machine learning. It is a branch of artificial intelligence that allows computers to learn from data without being explicitly programmed. Okay, now let's decode this definition step by step. Okay, it is a branch of artificial intelligence. Okay, if this is the curve of artificial intelligence, the machine learning is a branch of artificial intelligence. Okay, machine learning is a branch of artificial intelligence, and deep learning is a branch of machine learning. Okay, deep learning is a branch of machine learning. Okay, this is basically what it specifies. Okay, that allows computers to learn from data. Okay, that allows computers to learn from data. Now in machine learning, what you actually do is you take a model. Okay, you train the model on a certain data set. Okay, after model gets to learn from that data set, what it does is it's able to predict. Okay, it's able to predict on the new unseen data. Okay, now let's take an example. Now you have trained a model on dog and cat data set. Okay, now you're trained a model on dog and cat data set. Okay, now in future, okay, in future, to make predictions, when you give a new image of a dog, okay, when you give new image of a dog or cat, the model will be able to tell whether it's a dog or cat. Okay, this is basically what machine learning does. It is able to learn from the data set and is able to make predictions on the new unseen data. Okay, now without being explicitly programmed. Okay, this explicitly programmed is a new term. Now let's understand what actually is this explicitly programmed. Okay, explicitly programmed is nothing but you write and code for every instance. Okay, generally in traditional programming, okay, in traditional programming, when it comes to like Java programming or C programming, what you do is you write program. Okay, you write a program for every instance. Okay, now let's say you want to add two numbers. Okay, you write a code in this way: z is equal to x plus 5. Okay, now when in future, if you are asked to add three numbers, then what you do, b is equal to x plus 5 plus a. Okay, you again write a new piece of code. Now in future, again you are asked to write a code for adding the 100 numbers, then again you write a piece of code over here. Okay, this is what is meant by explicitly programmed. Okay, now without being explicitly programmed, how machine learning model is able to produce the output, let's see. Okay, now what you do is, now let's take the same scenario of adding the numbers. Now in machine learning, what you do is you train. Okay, you train the model on a data set. 2 plus 3 is 5. Okay, this is the input and this is the output. Okay, you train the model on the input and output. Okay, 2 plus 3 is equal to 5, like 4 plus 5 is equal to 9, 10 plus 20 plus 30 is some around 60. Okay, in this way we have data set. Okay, in this way we have the data set of inputs and outputs. Okay, now you train your machine learning model on this data set. Okay, after training the machine learning model on this data set, it is able to learn. Okay, it's able to find out the mathematical relationship between the input and output. Okay, it's able to find the mathematical relationship between input and output. Now in future, if you give the model of adding the 100 numbers, okay, now if in future if you give 100 numbers, the model is able to predict the output. Okay, the model is able to predict the output without being explicitly programmed. Okay, this is what meant by explicitly programmed. Okay, now let's see the basic difference of traditional programming and machine learning. Okay, in traditional programming, what you do is, you, for the computer or model, what you do is you give data and program as the input. Okay, data, you give the entire data and program as the input. Okay, now let's take this example. In traditional programming, or like C programming or Java programming, what you do, you give this variables as the input. Okay, this variables with numbers as the input, and you write the code. Okay, you write the code as well. So the that both becomes the input for the computer. And what your computer does, based on the program and the input, it's able to calculate the output. Okay, this is what is done in traditional programming. Now in machine learning, what we actually do is we give data and output to the computer. Okay, here when you see over here, this is the data and this is the output. Okay, you are giving data and output to the model, and your model is able to learn from data and output. Okay, it's able to calculate the mathematical relationship between the data and output, and it's able to build the logic. Okay, this program is nothing but logic. Okay, when you give data and output, your model itself is able to build the logic. But in traditional programming, you give data as well as logic as the input, and your computer needs to calculate the output. Okay, this is the basic difference between traditional programming and machine learning. Okay, now in the next section of the video, we'll be seeing the importance of machine learning. Now let's discuss the importance of machine learning with three generalized examples. Okay, among them, the first example is, let's say you and your friend has both went to a restaurant. Okay, now you know all the food taste about your friend. Okay, he prefers more spicy, okay, sorry, more spicy and more masala food. Okay, he prefers more spicy and more masala foods. Okay, now by seeing the menu, you are able to classify. Okay, by seeing the menu, you are able to classify based on these features. Okay, this is more masala and this is more spicy. Okay, now let's say our first food item is mutton curry. Okay, our mutton curry comes over here, and second food item is chicken curry, and third food item is some dal, and fourth food item is some prawns curry, and fifth food item is some roti curry. Okay, now these are the classifications. Okay, now you can clearly see that based on the features, here are two clusters. Okay, this is the cluster 1 and this is the cluster 2. Okay, now all the food items that fall under cluster 1 are preferred by your friend, and all the food items that fall under cluster 2 are not preferred by your friend. Okay, now let's say a new food item has come, which has fall over here. Okay, this is a new food item that has medium spicy and medium masala. Okay, now you need to decide whether your friend prefer this food item or not. Okay, as a human being, it is very much difficult to find out whether this food items fall under this cluster or this cluster. Okay, now here comes the role of machine learning. Okay, now what actually machine learning does is, it gets trained on the entire data set. Okay, now it's able to find why this cluster formed based on this input features, and why this cluster is formed based on this input features. And what it does is, it finds the similarity. Okay, it finds the similarity of this data point to this cluster, and this data point to this cluster. Okay, now this entire process is mathematical. Okay, this entire process is mathematical. Okay, now after finding the similarity, what it does is, it is able to find whether this data point, okay, this food items fall under this cluster or this cluster. Okay, this is how machine learning classifies a new food item, that is new data point. Okay, now as a human being, to decide whether this food item is preferred by your friend or not, it is difficult, but machine learning is able to do it comfortably. Okay, now let's take the second example. Okay, now in the second example, you are building an email spam classifier. Okay, now how actually this email spam classifier works is, now based on the few words in the email, it's able to classify whether the email is spam or not spam. Okay, based on the words, it's able to find whether the email is spam or not spam. Okay, let's say if your email contains sale or huge, if these kinds of words are present more frequently in your email, then your email is classified as spam. Okay, now to write programming, okay, to write traditional programming, what you actually do is you write an if else condition for each of the word. Okay, if this word is there, then again you check another condition if this word is there, and again when another new word comes, again you check for that new word another condition. Okay, in this way you write a lengthy code for traditional programming. But in machine learning model, what you do is, let's say you have only few words. Okay, let's say you have only few words, that is sale, huge, and some money. Okay, some money. Okay, now in this way you have few words. Now what machine learning model does is, it gets trained on this words. Okay, it gets trained on this tokens, and it's able to understand whether some in future, let's say big. Okay, a new word big has come in the email. Okay, this big word occurred very frequently in the email. Now this is a new word, right? Okay, this is a new word. Now, your email classifier built on machine learning model is able to understand this is a spam mail. Okay, this is a spam mail. But you may have a doubt that it is only trained on fewer words. Now, how it is able to detect this new word? Okay, now how it actually detects is, as it is getting trained on this data set. Okay, this words data set, it's able to find the similar words. Okay, it's able to find the similar words that are related to these words. Okay, your machine learning model automatically finds all the similar words related to this words, and it gets automatically trained. Okay, this is how machine learning model works. Okay, whereas in traditional programming, you again need to write another piece of code for the new word big. Okay, if in traditional programming, if this big word is not present, it gets classified into not spam, but it's actually spam. Okay, this is the importance of machine learning. Okay, now let's take the third example. Okay, in third example, you're building a dog cat classifier. Okay, now in this dog cat classifier, let's say you have various breeds of dogs. Okay, now for each breed of dog and cat, you need to write a separate if loop. Okay, if loop and else loop. Okay, but in traditional, okay, sorry, in machine learning, what you do is you train your model on different breeds. Okay, you train your model on different breeds of dog, and you train your cat on different breeds of dog. Okay, just to give input as image. Okay, now after giving input as image, what your model does is, it finds the, let's say this is the face of a dog. Okay, this is the face of a dog. What actually this machine learning model does is, it finds the distance between, okay, distance between eyes and nose, again eyes and mouth, and eyes and this cheek. Okay, it's able to find the mathematical relationship between the features. Okay, it's able to find the mathematical relationship between the features, and after finding the mathematical relationships between the features, it's able to classify, okay, whether the image is dog or a cat. Okay, now in future another new breed has come. Okay, another new breed has come. Now for the new breed, these features are much similar, right? Okay, these features, that is distance between the eyes and mouth, distance between the mouth and the nose, these features are similar for the any dog. Okay, so in this way it is able to classify whether a new breed is a dog or a cat. Okay, this is the importance of machine learning. Now you may have a doubt that this machine learning concept is a very old concept. Okay, but why is it in boom now? Okay, because in olden days, okay, in olden days we don't have enough data. Okay, we didn't have any enough data. that is label data. Okay, label data. Okay, in olden days we didn't have any label data. Okay, this label data is nothing but, let's say you're having a data with dog image and cat image. Okay, now, but as a person you are able to understand this image as a dog and this image as a cat. But how a machine learning model understands this image as a dog and this image as a cat while training is, you need to label. Okay, you need to label this image. Okay, you need to label this image as a dog and cat. But in olden days we didn't have this label data. Okay, there was lack of label data. Okay, so that is why machine learning models built in olden days are not performing well. Okay, are not able to perform well. Okay, so that is why in earlier days, okay, in earlier days, due to internet revolution, we have much label data, right? Okay, we have already many pre-processed data sets as well, like MNIST data set and dog cat classifier data set. We have many pre-processed data sets available. So due to internet revolution, we have got enough data. Okay, we have got enough data, so it is in boom now. Okay, it is in boom now. And second reason why it is in boom now is we have enough hardware. Okay, in olden days there were no GPUs to train a huge machine learning model. Okay, there were only CPUs available which are able to train a basic machine learning model. But there are not enough GPU. Okay, there are no GPUs. Okay, there are no GPUs to train a large machine learning model on huge data set. Okay, but in earlier days we have multiple GPUs available. Okay, we have GPUs with various features. Okay, so that you can train a huge data set. Okay, you are able to train even a data set with some millions of rows, and you are able to handle some millions of parameters as well. So we have enough GPUs in earlier days, so that we are able to train a complex machine learning model. Okay, these are the two reasons why machine learning is in boom in earlier days. Okay, this is the entire machine learning introduction. Okay, now in the next video we'll be meeting with another interesting topic. Hope you guys like this video. If you like the video, please consider like, sharing and subscribing. Thank you.